Hey there. In this video, I'm going to demonstrate how to solve an equation using separation of variables. Now, this only works on an equation that is separable, which means that I can write it as the derivative. So here, dy dx is equal to some function only of y times some function only of x. So we have to be able to factor the two equations out from each other completely in order to separate the variables. So here I have x times dy dx equals 4y, and I am going to be able to separate the variables here. If I divide by x on both sides of this equation, I get dy dx equals 4y over x, which I can think of that as 4y times 1 over x. And now it's two separate equations. Or y times 4 over x. That works as well. Okay, so it is separable. I'm going to go ahead and separate the variables by first multiplying both sides of the equation by dx. And then I'm going to divide just by y. I'm going to take the bare minimum over to the left side of the equation so that the y's will be on one side and the x's on the other. So if I divide by y, on the left I will get dy over y. And multiplying by dx, I get 4 over x dx. You can take the 4 over with the y if you want, but it's not necessary. Now I can integrate both sides of this equation. And on the left side, well, 1 over y, that is the natural log of the absolute value of y. And on the right side, the integral of 4 over x is going to be 4 times the natural log of the absolute value of x. And both of these technically have a constant of integration. I'm going to combine them as just a single constant of integration on the right side of the equation. And I am going to have to do some solving here, so I might be renaming this constant at some point. I'm going to call it C1, just so if I change it by either multiplying it by a constant or dividing it by a constant, then I can just change the name to C2. Now, I have natural logs on both sides. My goal is to solve this equation for y, so I get a final answer. And so I'm going to exponentiate here. Everything gets raised, gets put a base of e on it. So this left side becomes e to the natural log of the absolute value of y equals e to the 4 natural log of the absolute value of x plus c1. All of that stuff on the right side gets put into the exponent. Okay, so on the left side of the equation, that simplifies to just the absolute value of y. And on the right, it doesn't simplify quite so easily, but I can start to clean this up a little bit. I'm going to use an exponent rule to split up the sum. So this will be e to the 4 times the natural log of the absolute value of x times e to the c1. I can just rename that c2, that e to the c1. I'm going to hold off though and see if I can fold a little bit more into it before I rename it. So the next step on the left side is I need to get rid of that absolute value, and we can do that by throwing a plus or minus out front on the right side. So y is going to be equal to the absolute value of everything, or sorry, the plus or minus of everything on the right side. Now, simplifying that e, if you can see exactly how it simplifies, then go ahead. If you're not so sure, I can use an exponent rule to rewrite this as the natural log of the absolute value of x to the 4th. And then that's times the e to the c1. Now, x to the 4th is always going to be positive, so I don't even really need an absolute value on this anymore. So I can just kind of drop those out. And now the e and the natural log will cancel out like it did for the y on the left side, and I'm going to get a simplified answer. The plus or minus and the e to the c1, I'm going to rename that all as just c. And you can put a new subscript on it, but it's my final c and my final answer, so I'm just going to call it c. And then that e to the natural log of x to the 4th simplifies to x to the 4th. And there's my solution. Y is equal to c times x to the 4th.